All right, welcome to section 2.6, pre-calculus. You should be on page 16 of your packet. This is going to be an introduction to rational functions, and we will by the end be able to sketch them by hand. A rational function is a function that can be written in the form of f of x equals n of x divided by d of x. The n of x represents the numerator, and the d of x represents the denominator. Rational means as a fraction. So we're going to have a polynomial on top and a polynomial on bottom, and d of x cannot be equal to 0. D of x cannot be equal to 0, because then you'd have a division of 0 which is undefined. The domain of the rational function includes all real numbers except the x values that make the denominator 0. X values that will make the denominator 0. So you're going to want to figure out your domain because that's going to be a part of our polynomial functions. Find the domain of this function. You're going to take x squared minus 4 and you're going to set it equal to 0 and solve for x. And then x would equal plus and minus 2. So we know that the domain are all reals, but x cannot equal, because this is a not equal to, cannot equal 0, cannot equal 4, and so x cannot equal plus and minus 2. The 2 would cause a division of 0, and the negative 2 would also cause a division of 0 if you substitute them back into the denominator. What we're really focusing on today are horizontal and vertical asymptotes. Let's talk about the horizontal one first, or the vertical one first. The line x equals a looks like this. This is a line x equals a. Is a vertical asymptote of the graph of f if f of x approaches infinity or f of x approaches negative infinity as x approaches a. So basically what they're saying here is if I have a graph that comes along and slowly gets closer and closer to that vertical line, then it's approaching the line but never crossing it, then that is considered a vertical asymptote. You know, we may also see that graph come and go to negative infinity, but it's slowly approaching but never crossing. So this vertical line right here, x equals a, is a vertical asymptote. Horizontal line, y equals b, is a horizontal asymptote of the graph of f if, here we've got the same situation. So now I could have a horizontal line, y equals b, as a horizontal asymptote. As long as my graph slowly approaches it as it approaches infinity, then that is a horizontal asymptote.
Teachers that have questions on Power School scheduling, please report to room 330.
All right, that's what horizontal asymptotes will look like right here. And it's as x approaches infinity, and as x approaches negative infinity, it will get closer and closer to that horizontal line. They never meet, though. State the following asymptotes of rational function rules. All right, this is my rational function. You've got a polynomial on top, a polynomial on bottom. The graph of f has vertical asymptotes at x equals a if d of a is equal to 0. In other words, if your denominator is equal to 0, for whatever x values those are, that'll help us with finding our vertical asymptotes. Let me show you an example of that. If I've got f of x equals x over x minus 3. Since x cannot equal 3, x equals 3 is a vertical asymptote. That's what that would tell us, because this x equals 3 makes it undefined. So you got to find your domain here and figure out your vertical asymptotes. Horizontal asymptotes. The graph of f has one horizontal asymptote, so it's either one horizontal asymptote or no horizontal asymptotes, depending on the degree of n and d. Here's what you're going to do. These are 3 scenarios, and you're going to look at the degree. If the degree on top, the numerator, is smaller than bottom, if the degree is less than that of the denominator, so n is less than d, then your horizontal asymptote is y equals 0. If your n is equal to d, if the numerator's degree is equal to the denominator's degree, then it's the leading coefficients of a over b. You use the ratio of a over b. And the a over b comes from right here, those leading coefficients. And finally, if your degree on top is bigger than on bottom, you do not have a horizontal asymptote, not at all. I'm going to show you an example of all 3 of these. If your function looks like this, x squared plus 3x minus 1 over x to the third, the degree on top is 2, the degree on bottom is 3, so 2 is less than 3, then y equals 0 is the horizontal asymptote. Y equals 0. All right, another example. If f of x equals x squared minus 1 over 3x squared plus 7, the degree on top is 2, the degree on bottom is 2. So since 2 is equal to 2, then the ratios, you're looking at the numbers in front now. And the numbers in front would be 1 and 3. So your y equals 1/3 is your horizontal asymptote. And finally, if you have your function, f of x equals x to the third over x plus 1, your degree on top is 3, your degree on bottom is 1, so 3 is greater than 1, there's none. These are the 3 type of examples that you'll be dealing with when you're trying to find your horizontal asymptote. There can only be one horizontal asymptote at one time. In fact, you may see that there are plenty of times when you do not have a horizontal asymptote at all, and it's because the top power is larger than the bottom. All right, a couple other rules that we have to look at. Sometimes the graph will have a hole in it. A graph that has a hole in it might look like this. Maybe you have a curve here coming in, but there's a hole in the graph and then it continues. That's considered to be a hole. Holes are graphed with an open circle. You have a hole in your graph if there exists an excluded value that was simplified. It would happen in a case like this. If I have x squared minus 4 on top, and I have an x plus 2 on bottom, and an x minus 3 on bottom. So this is my rational function. This one would contain a hole because if I were to factor the top, if I factor the top into x plus 2, and x minus 2. And on bottom, it's already in factored form of x plus 2 and x minus 3. Since I have an x plus 2 on top and bottom, and negative 2 would be considered a 0, then the whole would occur at negative 2. So on this case, let's get rid of this graph here. In this case right here, my whole would be at negative 2, and then to find the y value, see, these would cross out. You would put negative 2 in. So negative 2 minus 2 over negative 2 minus 3. That's negative 4 over a negative 5, which is 4/5. So negative 2 4/5. This is where your whole would be in your graph. Now maybe the rest of the graph has a different behavior, but that's at least where you would identify your whole. Okay. Your whole is going to come from what you can cancel here. So since I can cancel this x plus 2 with 1 from top, that's the x value of your whole. All right, the second rule here that we've got is a graph will have a slant asymptote if the degree of the numerator is 1 more than the degree of the denominator. Something like this. If x to the third is 1 larger than the bottom, then that's the degree of the denominator. Or that's telling us that we have a slant asymptote. Here's how you find the slant asymptote. You will use long division. You put x to the third on the inside, and you'll put the x squared and 0x plus 1 on the outside, and whatever your quotient is, that'll be your asymptote. We will see examples of all of this in your next video.